Let's talk about the biochemical pathway of cortisol and testosterone production and why these two can be suppressive to one another and how exactly it is that they compete with one another within the HPA and HPG axis and the steroidogenesis process. So, cortisol and testosterone share a biochemical precursor which is known as pregnenolone. Pregnenolone is converted from cholesterol, and then from there, the body will decide whether to produce testosterone or whether to produce cortisol. What determines this is blood sugar levels, stress signals, energy availability, and sleep availability, among a few other factors. Metabolic stress prioritizes cortisol production over testosterone to stabilize glucose levels. So, what you need to know from this is if blood sugar is chronically low, then your body will stimulate the production of cortisol through the HPA axis, signaling the adrenal glands to produce cortisol. Cortisol will enter the bloodstream, and then it will have an effect on tissues such as muscle tissue and fat tissue to stimulate the breakdown of those tissues to create glucose, which then re enters the bloodstream and becomes available. This will raise blood sugar levels, and this process is called gluconeogenesis. When this happens, the body is in more of a sympathetic state, which means it's in a fight or flight activated state. This is a survival state, where the body is not going to prioritize growth, regeneration, and stimulation of the production of testosterone, because testosterone is really not so essential for survival when compared to cortisol. So, cholesterol to pregnenolone, which is the precursor for all steroid hormones. Pregnenolone can be converted into cholesterol via 21 hydroxylase or testosterone via CYP17A1 and 3 beta HSD enzymes. You don't really need to know that. You just need to know at some point pregnenolone is going to meet a fork in the road and it's going to have to decide either cortisol or testosterone, and your energy availability, your stress levels, and some of the environmental factors are going to determine which choice the body makes. So under stress with low glucose, whether it's from excessive fasting or whether it's just from physiological and psychological stress that's excessive, that will shut off or downregulate testosterone production, the body's going to take that available pregnenolone and convert it into cortisol. So more pregnenolone is diverted to cortisol under stress, which means less testosterone production. Cortisol will inhibit luteinizing hormone receptors on Leydig cells, which will further reduce testosterone synthesis. This is known as the pregnenolone cortisol steal response. So what happens here is because pregnenolone is the common precursor of cortisol and testosterone, the body's going to make a decision, and like we mentioned, this pregnenolone pathway, which can eventually go into cortisol, when the body is in a chronic stressed state, the pregnenolone resources are going to be continuously pulled away from the pathways that produce testosterone, estrogen, aldosterone, and some of these androgen hormones. So again, what happens here is the body will decide, it'll meet a fork in the road, whether we're going to convert from pregnenolone to dehydroepiandrosterone, also known as DHEA, and then eventually testosterone and potentially estrone and some of the estrogen hormones. But if it's not getting the correct signaling and it's under chronic stress, it's going to say, hey, I need to preserve the body. We're in survival mode, so I'm going to convert this. We're not going to go, this exit is blocked, and we're going to convert this pregnenolone, this precious pregnenolone, into cortisol instead to stabilize glucose levels. So this is what commonly happens when you fast for too long or your body's in a chronically stressed state and it needs to stimulate the production of blood sugar to increase energy availability, because again, it's sympathetic for the nervous system, it's fight or flight. You're going to mitigate and downregulate your production of testosterone. So finding a way to naturally balance this process and start to reduce the production of cortisol through the HPA axis and instead turn on the production of testosterone through the HPG axis is going to require putting your body into a less stressed state by potentially consuming more carbohydrates, which are supportive to androgen hormone production, especially testosterone, which will then have an exogenous impact on increasing blood sugar via nutrition, which means the body can sense that blood sugar is higher, which means insulin will go up, which means insulin sensitivity will improve, which means insulin can put glucose into muscle cells, which means cortisol is no longer required to stimulate the response of gluconeogenesis, which will increase blood sugar endogenously via some of the healthy tissues in the body. We want to limit tissue breakdown, which is also known as catabolism, and promote anabolism via providing the body with enough carbohydrates and lowering the stress levels to mitigate production of cortisol and increase the production of testosterone. Okay, so insulin plays a huge role in muscle growth, metabolism, and nutrient partitioning, which emphasizes the importance of insulin and having insulin sensitivity optimal for ideal body composition. So insulin is a storage and anabolic hormone that facilitates glucose uptake and amino acid transport into muscle cells. It helps replenish glycogen stores post-workout and ensures muscle recovery. It reduces muscle protein breakdown. So it really has an anti-catabolic effect and helps you preserve lean mass, i.e. insulin helps you build muscle. Insulin is most effective when sensitivity is high. So chronically high insulin due to poor diet, inactivity, obesity can lead to insulin resistance, which occurs with fat gain and metabolic dysfunction. The key takeaway is that insulin supports muscle repair, recovery, and energy production when it's managed properly. So insulin, again, acts as an anti-catabolic hormone. It prevents muscle breakdown by inhibiting protein degradation. It works with growth hormone and IGF-1 to support lean mass retention. It blunts cortisol post-exercise, which is why post-exercise carbohydrate uptake or nutrition is really key for reducing the stress-induced muscle loss due to training. Bodybuilders and athletes time insulin spikes via carbs post-training to reduce muscle breakdown, and low insulin due to prolonged fasting can increase catabolism, which is the breakdown of muscle for energy. Key takeaway here is that insulin's anti-catabolic properties make it crucial for maintaining muscle mass and recovery. Now, in terms of insulin and nutrient partitioning, insulin actually directs nutrients like glucose and amino acids into muscles instead of fat cells. You can see here that insulin acts as a key to the door that unlocks the cell. And when an insulin receptor is met up with insulin, it actually opens a glucose channel and allows glucose to enter the cell. When glucose enters muscle cells, it helps the muscles generate ATP and produce energy. So the more insulin sensitive you are, the more efficient your body will become at upregulating and partitioning glucose and amino acids into muscle cells, which will help them grow. This will also lead to better body composition over time. So post-workout carb consumption increases insulin sensitivity, which aids in recovery. And people with insulin resistance store more nutrients as fat or triglycerides instead of muscle. So there's a direct correlation between insulin sensitivity and body composition. Athletes with high insulin sensitivity experience better energy partitioning and recovery. So higher insulin sensitivity means more efficient glucose use, means better metabolism, and means leaner body composition. So to improve insulin sensitivity naturally, you really want to make sure that you get post-workout carbs because the muscles are primed for nutrient uptake. This will replenish glycogen and blunt cortisol. Strength training and HIIT will increase GLUT4 receptors. That is a glucose transport protein, which acts as a doorway to bring in glucose from the bloodstream into muscle cells for better glucose uptake. A whole foods diet, minimizing processed foods, will minimize insulin spikes and maintain this insulin sensitivity. Obviously, good sleep, stress management will help insulin sensitivity. Post-meal walks will help regulate blood sugar and mediate your insulin response. Taking magnesium and omega-3s will help support insulin function and metabolic health. Chronically high insulin leads to insulin resistance, metabolic dysfunction, and obesity. Managing insulin properly enhances your energy balance, performance, and body composition over time. So optimizing insulin sensitivity will maximize muscle growth, enhance fat loss, and improve your overall health. Insulin facilitates muscle glucose uptake and glycogen storage, which fuels workouts and recovery. It's an anti-catabolic hormone, which prevents muscle breakdown, and it enhances nutrient partitioning, which directs nutrients into muscle cells instead of fat, which is very, very key. Improving insulin sensitivity leads to better metabolism and leaner physique overall. So the big takeaway here, insulin, anti-catabolic, it's actually anabolic because it helps transport nutrients into muscle cells instead of fat cells. So managing insulin sensitivity properly is key to having an ideal, optimal body composition and very, very healthy physique. Okay, let's talk about growth hormone, also known as somatotropin. Growth hormone is a key anabolic hormone produced by the pituitary gland, and it influences IGF-1 production, anabolism, metabolic rate, body composition, etc. It's secreted by the pituitary gland, and it stimulates growth in bone, muscle, and connective tissue. It works synergistically with IGF-1 to promote hypertrophy and recovery, and it also triggers lipolysis, which is fat breakdown, which can improve your body composition. So growth hormone releases in pulses, with the largest spike occurring within about the first 90 minutes of sleep, and 70% of your growth hormone is actually released during sleep. So the key takeaway with that is that it's essential for tissue growth and repair and body composition regulation. Now, growth hormone also has a tremendous impact on muscle growth because it directly stimulates muscle protein synthesis, which supports hypertrophy and repair. It enhances satellite cell activation, which increases muscle regeneration post-training, and it increases collagen synthesis, which strengthens tendons, ligaments, and joints. So growth hormone is absolutely crucial for injury recovery, maintaining connective tissue integrity, and a deficiency in growth hormone release can lead to muscle loss, poor recovery, and weaker joints. So growth hormone is a really important anabolic hormone to support long-term muscle development and joint health. Now, in terms of fat metabolism, which is also known as lipolysis, growth hormone promotes fat breakdown, converting stored fat into energy. It increases free fatty acid mobilization, making fat a primary energy source. And then it also works synergistically with fasting and calorie restriction to optimize fat burning. Growth hormone deficiency is linked to an increased body fat percentage and poor metabolic function. And intermittent fasting can actually increase growth hormone secretion, but it has to be managed appropriately in order to prevent it from going into a catabolic state and spiking cortisol. Growth hormone enhances fat oxidation, making it a key hormone for fat loss and metabolic health. Now, you need to understand as well, GH and IGF-1, which is like the growth axis in the body. So growth hormone stimulates the liver to produce IGF-1, which is insulin-like growth factor 1. IGF-1 is the primary mediator of growth hormone's anabolic effects, which promotes muscle growth, and it also supports bone density, cartilage regeneration, and tissue repair. So IGF-1 levels correlate with muscle hypertrophy, longevity, recovery. Higher IGF-1 levels and higher growth hormone levels signal a better anabolic response to training, and chronic stress and poor sleep can lower both of these hormones. So this GH-IGF-1 axis is really fundamental for long-term muscle development and recovery. Growth hormone production is highest when the body is in a parasympathetic state, meaning it's resting and digesting, as anabolism or muscle tissue growth and repair is not a survival mechanism. It's actually more of a nice to have for the body. So the body will only trigger the release of these hormones when it has the environmental triggers and the energy resources to actually repair itself, which means cortisol is actually suppressive to growth hormone because cortisol is released in a sympathetic state, which is fight or flight, which actually inhibits the muscle repair and tissue growth process because cortisol is catabolic. So this is where there's a tricky balance when it comes to fasting, as fasting can stimulate the release of cortisol to enable the increase in subsequent blood sugar and fasting blood glucose levels, but also fasting, when done properly, can trigger growth hormone release, which enhances lipolysis and fat burning. So there is a lot of talk out there about mTOR, whether mTOR causes cancer or whether mTOR is good or bad. And what I want to do is just cut through the noise and really tell you what it is, what it does, and then why it should be regulated throughout your lifespan. So mTOR, mechanistic target of rapamycin, is a nutrient sensing switch. It is a metabolic pathway. In fact, there's two of them, mTOR-C1 and mTOR-C2, and they do very different things. mTOR is crucial. It needs to be activated in order to put your body into either an anabolic state or a growth state, in order to repair tissue, utilize nutrition, utilize energy, and mitigate stress, in order to help the body adapt and grow. Not just good or bad, it's not just black and white. It's very myopic to look at mTOR and say, let's do everything in our power to reduce activation of mTOR. That just doesn't make any sense at all. The body will regulate mTOR for you. All you need to do is give it the proper signaling in order for it to take effect and have the proper effect on your cellular function downstream. So, mTOR, nutrient sensing switch that integrates training, nutrition, energy availability, and growth factors to regulate muscle growth, protein synthesis, and cellular repair. Mechanistic target of rapamycin. It's a central regulator of muscle growth and metabolism. So you want mTOR pathways to be healthy and well regulated, not turned on or off at all times. Things that trigger mTOR: resistance training, amino acids, growth factors like IGF-1, insulin, and testosterone, energy status or ATP availability. And when activated, mTOR triggers an anabolic growth promoting response, leading to increased protein synthesis, enhanced muscle repair and recovery, greater muscle fiber growth, also known as hypertrophy. And mTOR is extremely important for muscle growth because the activation is what triggers hypertrophy. Muscle size increases only when mTOR is sufficiently stimulated via resistance training and having enough energy and nutrition available to promote protein synthesis. So mTOR directly controls the rate of protein synthesis, which determines your muscle building potential. Satellite cells, which are muscle stem cells, are activated by mTOR, which leads to new muscle growth and improved strength. So there are two mTOR complexes, mTOR C1 and mTOR C2. You can see them right here, C1 and C2. mTOR C1 is the primary pathway for muscle growth, which is activated by nutrients, amino acids, especially leucine, energy availability, which is just ATP, and then growth factors. So having sleep, regulated levels of stress, testosterone, IGF-1, insulin, and then also the input of mechanical stress, i.e. strength training. This leads to anabolic metabolism, muscle growth, and inhibits catabolism, which is just your muscle breakdown. And then mTOR C2, which is more about cell survival and cellular structure, cytoskeleton rearrangement. It's activated by growth factors and mechanical signals as well. So, cell survival, AKT signaling, cytoskeleton and movement, important for adaptation to resistance training. And then key takeaways for practical application with mTOR is it needs to be activated regularly to build muscle and strength. And the best ways to activate it is heavy resistance training with progressive overload, an adequately protein-rich diet, which contains leucine, which you can find in beef, eggs, and whey products, adequate calorie and ATP availability, so avoid extreme fasting and excessive calorie restriction. It'll inhibit mTOR C1, which will reduce your ability to build muscle. Optimize testosterone and IGF-1 through sleep and regular stress management, mitigating cortisol levels. But really, mTOR is the master switch for muscle growth. So you want to train hard, eat well, and recover properly to make sure that it's regulated and activated at the right times. And this will also enhance your ability to build muscle and strength, which will contribute to your longevity in the future.